It's been 13.8 billion years. We have galaxies, we have stars, we have black holes, we even have conscious life. And you can't even make it to your 8 a.m. Let's talk about it. The universe starts out as basically nothing. There's no atoms, no space, completely unstable vacuum. And then boom, the first 10 to the 32 seconds of our universe, the inflationary epoch starts. This is when the universe is expanding faster than the speed of light. And our small, tiny little universe expanded and cooled by a factor of 10 to the 26. And by the time we get to 1 microsecond or 10 to the negative 6 seconds, the first particles start to form. The universe is a boiling soup of quarks and gluons, which is called plasma, and these conditions were actually replicated at CERN's Large Hadron Collider. And there's just a primordial soup of particles, no structure, no atoms, just energy. And now we start to see the influence of the 4 forces that we know and love. Strong nuclear force, which holds up atomic nuclei together. Weak nuclear force, which allows for particle identity change. Electromagnetic force, which is responsible for the interactions between electrically charged particles. And gravity, which is responsible for the interactions between anything with mass or energy. And now we get about 3 minutes into the life of the universe. We call this era nucleosynthesis. The universe has cooled down just enough for nuclear fusion, and by just enough we mean 1 billion Kelvin. Protons and neutrons smash together to form hydrogen, helium, and lithium, and now you have the basic elements of the universe. But there are no complete atoms just yet. It's still too hot for any nuclei to catch any electrons and form full atoms. Electrons were bouncing everywhere, and light couldn't travel very far because these electrons would smash them in the face and refract them every which way. Thus, light was completely scattered, and our entire universe was just a very opaque and foggy haze. And now we get to the first 300,000 to 380,000 years of the universe. We call this era recombination. The universe has cooled a lot by now. Full atoms have been created, and 2 things happen. The first thing is that the fog clears and light can finally move freely in the universe. The second thing is that atoms released energy in the form of light through nuclear fusion. Because of these 2 things, the light was now able to travel far and wide distances throughout the entire expanse of the universe, right? Now, if we zoom out a little bit, we can see that light's still there, and it appears like this. This is the cosmic microwave background radiation. We call this the afterglow from the very beginning of the universe. This is the relic radiation that came from light finally being able to escape and travel far and wide distances. And now we enter a kind of boring phase. It's called the Dark Ages. And I'm not talking Dark Ages as in the early Middle Ages when people used eels as currency and wore really pointy, weird shoes. Although shoes are still weird now. I'm talking about the period after recombination that lasted around 1 billion years after the Big Bang. At this point in time, the universe was shrouded by hydrogen, which would absorb any free photons. Now let's time skip to about 200 million years later. The first stars start to form. This is the start of the stellar era, where stars burn, explode, and reform. And it's just stardust recycling over and over. And at this point, we are about 12 to 15 billion years before the present. Now, from the inflation era to up until about 5 billion years ago, the universe was expanding, but it was slowing down as it was expanding. At around 5 billion years ago, we start to see that the expansion starts to speed up again. And now we start seeing the influence of dark energy. We don't know what it is, we can't detect it, and we only know it exists because galaxies are running away from each other. Check my last video for more information. And now let's time skip to around 4.6 billion years ago. This is around when the Earth and the Sun start to form from a cloud of gas and dust called the solar nebula. Skip to 3.8 billion years before the present, we start to see that Earth develops an atmosphere and starts cooling. The sea of magma around Earth encouraged the creation of this atmosphere by releasing gases such as nitrogen, hydrogen, carbon, and oxygen. Microscopic cells start to appear around volcanic areas. This is because volcanoes release phosphorus, which is essential for the creation of RNA. Rain falls, oceans form, cells start replicating in volcanic muck, and we've got life. Time skip to 700 million years ago, we start to see the emergence of primitive animals. Skip to 200 million years ago, we start seeing mammals. 65 million years ago, we see the dinosaurs going extinct. 2.5 million years ago, humans show up. Oh God. As early primates or hominines, we were called Australopithecus, or the southern ape, and we resided in East Africa. Once we evolved into Homo erectus, we started to migrate out of Africa to Asia, Europe, and Southeast Asia. Different groups started to evolve on their own. Up in Europe, we got the Neanderthals. In Siberia, we got the Denisovans. In Asia, we still got Homo erectus, and in Java, we have Homo soloensis, and much more. And here we are as Homo sapiens, which are theorized to have come from Homo erectus. Can you imagine if we all coexisted, like Neanderthals and Homo sapiens filing taxes together? Actually, that's pretty awesome. Up until 100,000 years ago, sapiens win the evolutionary war, and we find ourselves at the top of the food chain. We build civilization, we invent languages, agriculture, Wi-Fi, brain rot, and then we start streaming videos to random strangers online. And now, on a very hopeful and optimistic note, let's talk about how it all ends. So there are a few theories about how it all ends. The most accepted one is that we fade away slowly. So from about 100 trillion years to 10 to the 37 years into the future, all stars die. We call this the degenerate era. But if you ask me, I'd say we're in the degenerate era right now. And then we get into the period from 10 to the 38 to 10 to the 100 years. We call this the black hole era. In this period, black holes are the only thing that remain in the universe. All matter either decays or gets swallowed up by the black hole through Hawking radiation. And then we've got the dark era. Eventually, everything is gone. No stars, no black holes, just low energy photons in infinite space. Any activity in the universe is very low impact. Everything is basically a void. Depressing, right? Well, this is only assuming that the universe doesn't recollapse within itself. If that were the case, then instead of everything I just said, what would happen instead is expansion of the universe would slow, it would stop, and then it would start reversing. It's like you're going back in time and the universe is getting smaller and smaller and smaller and smaller, back into that point where it started. And then, boom, Big Bang starts again, and then the whole cycle starts up again. Inflationary period again, dark ages again, planets form, life starts, people decide that Cybertrucks look good, all sorts of disasters. In 13.8 billion years, the universe made atoms, stars, and life itself. And I'd like you to acknowledge that we are the universe experiencing itself. We are so seemingly insignificant in the entire scheme of things, but the chain of incredible and specific events that had to happen for us to even get here, for us to gain consciousness as a species, and for us to even understand any of this science, that's significant in and of itself. And so stars were born and they died for millions upon millions of years, just for you to doom scroll on your bed at 2 a.m. Thanks, guys.